In this video, you will learn how to use the Zoom Box feature, which allows you to zoom in on a specific area of the graph. You can use the Zoom Box feature to get a clear picture of a graph in an area where it is not clear what the function is doing. Another use of the Zoom Box is to enhance the view of the intercepts or where two functions intersect. The next three examples will illustrate the advantages of using the Zoom Box feature. So let's go to example number 1. Recall the last example in the video, finding a good window. We graphed the function y equals negative 0.005 x to the fourth plus 0.8 x cubed minus 2x squared plus 7x minus 6,000. After using the table, a good viewing window was found, as shown on the screen to the right. So let's input the function and the values for the window. So let's go to y equal, and we have negative 0.005 x to the fourth power plus 0.8 x cubed minus 2x squared plus 7x subtract 6,000. And let's go to the window button. So let's go ahead and input these values. So that's negative 100, and that went to 200 with increments of 10, and the y min was negative 50,000, and the y max was 350,000, and the increments were 50,000. Okay, and let's take a look at that graph. Okay, so this is what we had last time. So from this window, it is unclear what the function actually looks like around the origin. You can see, like right around in this area here, it's a little unclear what's going on. So we would like a better view of the x and y intercepts. I mean, we can tell that we are crossing the y-axis somewhere here, and we're crossing the x-axis right here. Now, this is where the Zoom Box feature really comes in handy. So what we're going to do is we hit the zoom, and then the first option here says Z box. So we just hit enter. Okay. Now notice right here on the screen a little cursor popped up. Okay, so if we move that to where we want the corner of the box to start, it doesn't really matter where you start it. I usually start it with the upper left hand corner of the box. So I'm going to move it over to the left, and now I'm going to move down a little bit because I want to really zoom in on what's happening in this area right here. Okay, so I'm going to move down a little farther. Okay, now let's go ahead and hit enter, and that gives you the first point of the box, the upper left corner. So now I'm going to move down and start forming the box, and you can see that the left hand side of the box is forming. So move it down a little bit further. Now I'm going to move it to the right, and now you can see the box really taking shape. And let's move it a little bit past where the x-intercept is. Okay, so what's going to happen now is it's going to draw a zoomed in picture of just this area. So what I need to do now is hit enter. And there it is. you can see that this function actually barely comes up and it doesn't hit the x-axis at all, which it kind of looked like it did from the previous picture, and you can see that on the screen to the right there, and then we come up and we hit our x-intercept right here. So that's an advantage of the zoom box. You get a clear idea of what's actually happening. So let's go to example number 2 now. So let's go back to the y equals and clear this function out. And let's go back to zoom and then the standard viewing window. Number 6. Okay, so let's quit out of this. And there we go. So we're ready to input the function. So here we would like to graph y equals 5 divided by 8x squared minus 15. So let's input this rational function. So that's 5 divided by 8x squared minus 15. Now, I purposely made a mistake here because remember we talked about this quite a few videos back, that we need to follow our order of operations, and what's going to happen here is that it's going to take 5 divided by 8x squared, this value, and then subtract 15 from it. So remember, we need to put parentheses in the denominator. So let's move back to the beginning, and we go second function and then insert, and that allows us to insert a left-hand parenthesis, and then we can move all the way to the end and put a right-hand parenthesis on it. So now it's going to take 5 and divide it by this whole quantity, and that's what we want. Now we can go ahead and hit graph. Okay, now you can see that this graph fits into the standard viewing window, but it is difficult to tell if the lower half of the function touches the x-axis. So we will zoom in on the area to see what is happening. Okay, so on the lower half it's kind of hard to see, does this actually touch the x-axis or not? And then also, it looks as if the upper half of the function in quadrant 1, so right here, it looks as if the function kind of ends, maybe somewhere between 2 and 3. So here in quadrant 2, it looks as if it also ends between -2 and -3. Is that an accurate representation of this function? Well, what we can do is let's zoom in on this and see exactly what's happening. Alright, so first I'd like to zoom in on just the lower half of the function. So let's go ahead and hit the zoom, and then remember Z-box, so hit enter. Okay, now you can barely see it, but right there you see a little flashing dot, and that's where the cursor is. Okay, see that flashing right there. So I'm going to move it up a little bit, and then move it to the left, and then right there I'm going to hit enter to start the left-hand part of the box, and then move down, and then I'll move to the right, okay, and then hit enter. So you can see that in reality the function does not hit the x-axis, which is right here. It's slightly below it. And you can see the cursor flashing right here, and if you notice it gives you the coordinate of the x value and the coordinate of the y value. So the ordered pair right here is going to be 0.106 minus 0.323. Let's go back to the zoom window and press number 6 for zoom standard. And let's do another zoom. Let's figure out what's actually happening with these parts of the graph. Now, if we zoom in on this one, the same thing's happening over here because it's symmetric. So let's just zoom in on this part of it. Zoom, and then number 1 for zoom box, or you could hit enter, doesn't matter. So let's move the cursor up and a little bit to the right. Okay, so I'm going to start the left hand corner of the box right here. So let's hit enter and let's move it down and let's move it to the right. Start forming the box. Okay, so that should be good enough right there. So let's see what's actually happening. We'll hit enter. And there's the function. So it looks as if it starts to touch the x-axis here. Now remember that this is an asymptote. Okay, so it really shouldn't touch. So let's zoom in again on this area. And what's nice about this Z-Box feature is that you can keep zooming in on a specific area. So here's the cursor. If I hit enter again, then I can make another box. So let's move this down. And then over to the right. So let's just zoom in on this part right here. And let's hit enter. So you can see when we zoomed in, it actually is not touching the x-axis. And then we can zoom in one more time. Let's hit enter and then create our box again. And let's move it to the right and form our box. Okay, this is zoomed in very close because look, here between here and here is one increment. Okay, so that's 1 unit. Alright, so let's hit enter. And you can see it zooms in even closer. Alright, so that's a nice feature, and we could keep zooming in and keep zooming in. So let's go ahead and go back to Zoom Standard, number 6. And there's the original function. So we actually see the upper right and left of this function goes, and it doesn't hit the x-axis, and it actually doesn't end, as we discovered when we kept zooming in. And the lower half of the function does not touch the x-axis. It's actually a little bit below it, as we saw. Okay, so let's go to another example, but first let's clear this function out. And let's go quit. Okay, so example number 3, we would like to approximate where the intersection points occur for y equals the square root of 2x subtract 5 and y equals 0.3x. So let's input those graphs. So y equals the square root, so second function square root of 2x minus 5. Close the parenthesis and then enter, and then we can input the second function, which is 0.3x. And let's graph this. We can see the square root function is this one right here, and then the linear function is this one right here. So it looks like the linear function is going to intersect the square root function somewhere out over here. So let's hit window. So let's move a little bit further out on the x-axis. Let's go to, let's say 25. That should do it. And let's hit graph. So there's our square root function, and there's a linear function. Okay. Now in this window, it is difficult to see exactly where the points of intersection occur. Well, we can kind of see something maybe around here. It's not really accurate. And then somewhere here. I mean, it's kind of blended together. So is it happening exactly here? Is it exactly in the middle? Is it over here? Where is it exactly happening? So this is where the Zoom Vox feature would come in handy. So we can zoom in on each individual intersection separately. Okay, so let's zoom in on this one first. So let's go Zoom, ZBox, so hit Enter. Okay, and there's our cursor. Sometimes it's hard to see, so you need to look for it. And there it is. So let's move it up a little bit. And let's go to the left. So let's go one more. So it's about right there, the upper left-hand corner of the box. We'll select Enter and move down. And that should be good. And then move to the right. Stretch the box out. And that looks like it'll cover the first intersection point. So let's hit Enter. And there's a much clearer view of one of the intersection points right there. So remember that we wanted to approximate where the intersection occurs. So here's the cursor. So remember, here's the ordered pair of where the cursor is. So if we start moving it, we can put that cursor right on the intersection point just to get an approximation. Later on in another video, we will show you specifically how to find the exact ordered pair of the intersection. So I'd say about right there. So at approximately 2.8 and 0.796 is where the intersection is occurring. So let's go ahead and go to Zoom Standard, number 6. And let's go back and adjust our window so we can see the other intersection point. And remember, we set that to 25. And let's go ahead and graph that. Okay, so we're going to zoom in on this area right here. And let's go ahead and do that. So let's go to Zoom and then ZBox. So Enter. And there's our cursor right there. So let's move the cursor a little bit to the right. Let's move it up a little bit so you can see it a little better. So there it is. So let's move it to the right some more. And let's move it up. Now here I'm starting in the lower left-hand corner, which is fine. And let's hit Enter. And let's move it up. And let's move it to the right. Okay, and that looks like it covers the area where the intersection occurs. So let's hit Enter. And there it is. So it's still kind of unclear exactly where that intersection is occurring. So let's zoom in one more time on that. Let's go ahead and move the cursor over a little bit to the left. And let's hit Enter. Let's move up. And go to the left. And that seems good. So let's hit Enter. Okay, a little bit better. So approximately right there. So let's move the cursor around right here and move it down. So at approximately 19.4 and 5.8 is where this intersection occurs. Now let's go back to the zoom standard, zoom and then standard number 6. And I'd like to show you one more thing here. So let's change the window on the X max to 25. Graph that. Okay, let's make a little bit different box. Let's make a box where we're going to zoom in on just this particular area. So let's go zoom and then box, Z-box, so we hit enter. Let's move the cursor up. And then over to the left a little bit. Sometimes if you take a bigger zoom area, you may get a little bit clearer picture of the intersection point. So that's what we're trying to do here. So let's go down and let's move it over to the right now. Kind of takes a while when you keep clicking the cursor, but it eventually will cover the area that you want. Okay, so that looks pretty good right there. So let's go ahead and hit enter. So this gives us a little clearer picture of the intersection with that zoom. And let's move the cursor over. And let's put it on that intersection point. So I'd say about right there. So here we have 19.3 and we have 5.8, which is very close to what we had before. And you can see that just to your right on the screen, the intersection point. So if you didn't like the view that you originally had, you can always zoom in on a different area. And sometimes taking a bigger area works better than concentrating on a smaller area. Before we conclude this video, there's one more option under the zoom menu that I would like to discuss, and that's called the zoom previous. Now, that's not used often, but every once in a while it could come in handy. So let me show you how to use it. I'm going to go back to example number 2, and here's the function I have already inputted it, 5 divided by the quantity 8x squared minus 15. Okay, and if we graph that, remember this is what the function looked like. So let's say that we want to zoom in on the lower half of the function. And let's go ahead and hit zoom. And then zoom box is what we want, so we hit enter. And there's the cursor flashing right there. And let's go ahead and zoom in on this particular area. Here's what I want. Okay, so let's hit enter. And we'll move the cursor down. Starts forming the box, and we'll move it to the right. You can hold the arrow key down and it moves the cursor a little bit faster. Okay, and then let's go ahead and hit enter. So there is the area that I zoomed in on. Now let's say that I didn't like this area and I wanted to change it. Okay, I could go back to the previous window, or I can go back to the previous zoom. And the way you do that is you select zoom and then you go over to memory. And then here you can see Z previous, that means zoom previous. And if I select enter, this should take us back to our previously zoomed window. And there you have it. Okay? So let's zoom one more time. If I go back to zoom and then memory, if I hit zoom previous, it'll take me to the zoomed in area that we just saw, and there it is. Okay, so if I zoomed in one more time, if I hit zoom and then ZBox, hit enter, and let's say that I just want to look at this portion right here that I'm selecting. So I'll move the cursor up. Okay, let's say I'm zooming in just on this part right here. Okay, and if I hit enter, there it is. And you say, oh, that really didn't help me too much. I can always go back, and remember, you hit zoom, and move over to memory, and then Z previous, and I select enter. So then it takes us back to the previous window. Now, remember, this only goes back or forward only once. Okay, so if I hit zoom and then previous again, to memory, it's going to take me back to the window that I didn't want. Okay, so it will go back and forth between those two zooming windows. Alright, and that's all I wanted to discuss before we end this video. This concludes the video on the zoom box capabilities of the calculator.